Let me give you another example of when the table diagram method breaks down. So here with 3 coins, we're going to flick 3 coins. What is the probability of us getting all the same faces? So here we could get heads, heads, and heads. So that would be a good outcome. So tail, heads, tail here. This would be a bad outcome. Well, they've all got to be the same. Okay, so tail, tail, tail. So to work out the probability here, normally if we have only 2 coins, then we can use a table diagram. This here would the row here would represent our first coin, and then the column here would represent our second coin. But you see, with three coins, the table method breaks down. So this is why we need the tree diagram. So here, start with this coin here. Pretend you flicking it. So you flicking the first coin could be it could be a head or it could be a tail. Okay. Suppose you get a head on the first one, then you would jump to the second coin here. Then you would basically get a head on the second coin or a tail on the second coin. And let's say you get a head, and then you would move on to the third coin. So here you could get a head with the third coin, or a tail here. Okay, and well, if you continue with this, you're going to get heads here, tail here, and then here it branches out like this as well. So again, head, tails, and then here, heads, tails. So you can see that there are hang on, 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes with 3 coins. There are 8 possible outcomes. So here it would be a half to get the probability of getting a head would be a half. Probability of getting a tail would be a half. Well, this is quite a simple example. So all these are halves. Okay. But the branch that we were interested in would be a head, and a head here. Okay. So the probability of us getting probability of getting a head here would be this, and this. So when it's an and, you've got to times. So basically you're going down this whole branch here. So they're all multiplying each other. Okay. So it would be this. So the probability of you getting a head, and a head would be 1 over, well, this times this would be 4. 4 times 2 again would be 8. So it would be an 8. Okay, and then you've got to think about getting well, probability of tail, tail, tail. That's also a good outcome there. So again, tail would be well, we're going down this branch here, tail, tail, and tail here. So it would be times a half, and then times a half again. So this would be also an 8. But the thing is, we've got 2 branches here. 1 and then 2. Don't forget, this tree diagram is really in a way a map for all the possible routes that could happen. Well, we could have gone down this route or this route. So remember, when it's an or, you need to add. So it's basically this route or this route. So you've got to add these two together. Okay, so probability of same, all being the same, would be a half, an eighth, plus an eighth. So that would be 2 over 8. Well, you can simplify that. That would be 1 over 4. Okay, so the probability of you getting all the same face would be a quarter, or roughly 25, or 25